Good morning, this is your math sensei, Mr. Spensei, and today we're going to be working on literal equations. So we're still solving equations. We're going to follow the same rules, but we're working on literal equations. That means we're not going to get an actual answer. We're actually just going to be rearranging. Now, the good thing about literals is uh, you don't have to worry about having math errors. You're not going to add and subtract incorrectly. The bad thing is people get scared because it's all variables or mostly variables. So we're going to practice what we know by turning solving for x on an equation, and then we're going to turn it into a literal equation. That's how we're going to start. So we have the formula y equals mx plus b, which is the slope of the line, and you've seen that before. And it says substitute 10 for y and -2 for m and 16 for b. So if I do that, we're going to have 10 equals -2x and 16 for b, so plus 16. Then it says solve for x. Okay, well, I need to move my constant away. So 16 is my constant. So I'm going to do a -16 on both sides. This goes away. And now I have -6 equals -2x. I'm going to divide by -2. And I end up getting x equals +3. And the reason I know it's a positive is I can go back to the triangle and I have two negatives equals a positive. So that's what we get there. So describe the steps we use to solve for x. Well, what did we do? I guess we moved the constant plus 16 by minusing 16, and we divided by the coefficient of -2. That's how we did it. All right. Well, I'm going to remind you, we moved the constant +16. Well, that 16, that was really b. In this case, the coefficient of -2, that was m. So what we did was move the constant b, and then we divided by m. So let's try it out here. Use the steps developed above to solve for x. Well, we have y equals mx plus b. All right, we're going to move the constant b. Well, it's a plus b, so I need to do a minus b. Now, I want to talk for just a moment. B minus b, that's easy. That goes away. That's 0. Can I combine these? Are those the same letter? And the answer is no. So I can't combine them. So that has to be y minus b equals mx. Well, we're looking for x. And these two are side by side. It's like they're in parentheses and being multiplied. So how do I separate them? Well, if this is multiplication, I have to separate by division. And this crosses out. And I end up with y minus b over m equals x. And that's my answer. So this time we're going to do the same thing, except we're looking for m. We're going to solve for m. As always, we move constants before we get rid of coefficients. Well, I need to move this b, so I need to do a minus b, and this goes away. And now I have y minus b equals mx. Y minus b equals mx. Well, I'm still looking for m, and it's side by side with the x. So what do I need to do? Well, if I want the m, then I'm going to have to divide by the x because they're multiplied. So this crosses out. I have to put the x here. So I end up with y minus b over x equals m. So the last one of this type, it says y equals mx plus b, solve for b. This is easy. I have two terms on this side. I need to move this entire term. Now this doesn't have a sign on it, so that means it's plus. So I want this b by itself, but I need to move the mx. Well, how am I going to move a plus mx? Well, I'm going to put a minus mx. So now I have y minus mx equals b. So my answer is b equals y minus mx. Describe the steps used to solve for b. I don't know. What did we do? Oh, we subtracted mx from both sides. Why did we do that? We did that because we wanted to isolate b. We wanted to get b by itself. All right, so here we're given the simple interest formula. I equals PRT, and it says solve for R. Well, first off, I'm going to rewrite that with parentheses just because I think it helps understand what's going on. What it says is we're multiplying P times R times T. Well, if I want the R by itself and the P and T are multiplied by the R, what do I do to get rid of it? Well, how do you undo multiplication? Well, Mr. Spencer, you do it by division. So this means I need a P down here and a T down here. But if I did it to one side of the equation, I have to remain balanced. So I have to put a P and a T over here. Probably good to put them in parentheses, but not required. So this crosses out, this crosses out, and now I have R by itself, and I have I over P T equals R. So my answer is R equals I over P T. The next one says solve for P and T. And in class, we only solve for one of these, but I'm going to do both of them here. So first off, I equals parenthesis P parenthesis R parenthesis T. And we're going to solve for P. That's what we're going to do first because it asks us to solve for P. Well, this is multiply, and I have to do undo multiplication, so I need to use division. So I'm going to divide by R and T on both sides. So I end up with I over RT equals P. The next thing I want to do is I want to do the exact same thing, but I want to solve for T. Well, once again, I equals parenthesis P parenthesis R parenthesis T. And we're looking for T this time. Well, I'm multiplying, so I have to undo multiplication, which means I have to use division, and I want the T by itself, so I need to get rid of the P and I need to get rid of the R. Remember, we're continuing to use opposite or inverse operations. So I over P, I over P R equals T. All right. Moving on to the next page. It says D equals M over V. Solve for V. All right. We're going to solve for V. This is a typo. I need to get this fixed. But we're going to solve for V. All right. So D equals M over V. Well, it's a fraction. We don't like fractions, but we can fix this by multiplying both sides by V. Because this is dividing by V, so now we're going to multiply by V. So this will become VD equals M, so my answer is M, So I have VD equals M, but that's not what I want, because what I wanted was V. But anytime V's, whenever it's in the denominator, you have to multiply whatever you, if it's in the denominator, I have to multiply by it. Well, I still want V. Well, this is the same as having V times D. Well, if I divide both sides by D, I get V equals M over D. And that's the answer I was looking for, because we wanted V by itself. Please remember, if it's in the denominator, you're going to have to multiply. This one's so easy. We actually already solved it while we were solving the other problem, so it should be very, very quick. D equals M over V. Oh, I want the M by itself, but it's being divided by V. So I need to multiply both sides by V. The V's go away. And now I end up with VD equals M. And that's the answer I was looking for. M equals VD. All right. The next one, we're supposed to solve for W. So we have basically V equals, and I'm going to rewrite this, because this is 1 times this divided by 3. So I can rewrite this as L parenthesis W parenthesis H parenthesis all over 3. And just so you know, I'm going to put a 1 up there. Now, the fact of the matter is 1 times anything doesn't matter, so I really don't need it, so I'm going to scratch it out. But I do need everything else. That is the same thing as what we had right there. All right. And it wants me to solve for W. So here's W right there. I want it by itself. Well, what's bothering us is we have this 3 in the denominator. So I'm going to multiply both sides by 3. This goes away, and I have 3V equals LWH. Well, I'm still looking for W, and it's being multiplied by L and H. How do I undo multiplication? Well, you do division. So this becomes L and this becomes H. Well, this cancels out and this cancels out, but I have to do it on this side. So now I have 3V over LH equals W, where the final answer is W equals 3V over. All right, continuing on. They want us to solve for L. I'll make it a capital L so you can see it a little better. And I'm going to rewrite the equation. And once again, what it really means is V equals 1 parenthesis L parenthesis W parenthesis H parenthesis divided by 3. Okay, well, the 1 really doesn't matter, because 1 times all this stuff doesn't change it. 1 times 5 is 5. 1 times 10 is 10. 1 times L is L. So this doesn't matter. So I don't need it, but I need that 3. Well, that 3 bugs us, so we're going to, since it's dividing by 3, we're going to multiply by 3. All right. Well, those cancel out, and now I have 3V equals LWH. But we're looking for L. And remember, these are essentially in parentheses because they're side by side, which means we're multiplying. We undo multiplication by division. So this drops off, this drops off, and we have 3V over WH equals L. So L equals 3V over. All right, we're looking at our last example. Oh no, we still have a fraction. Well, we're going to use the same thing we did before, where we put the 3 in the denominator, except this time we're going to put the 2 in the denominator. So I'm going to rewrite this. A equals 1 parenthesis, B parenthesis, H parenthesis, because that's showing it's all being multiplied, divided by 2. Well, what are we looking for? In this case, we're looking for H right here. So the very first thing I'm going to do is get this 2 out of the denominator and put a 2 here. So now I have 2a equals, and do we need a 1 times anything? No, because 1 times 2 is 2, 1 times 3 is 3, 1 times b is b. So now we have 2a equals bh. We still want that h, and these things are being multiplied. We undo multiplication by division. So we end up with 2a over b equals h. And same problem, but we want to solve for b. Well, this is the same thing we just did. And we're going to write 1 parenthesis, b parenthesis, h parenthesis. The 2's in the denominator, that bothers us. So this drops off. Make sure we multiply both sides by 2. Now we have 2a, and 1 times 6 is 6, 1 times 10 is 10, 1 times 100 is 100, 1 times b is b, so I don't need this 1. So b, h. All right. Well, we're looking for b. So I need to get rid of this h. Well, this is multiplied, so I need to divide. So I have 2a over h equals b. So b equals 2a over h. All right. Hope this helped on literal equations. If you got questions, come see me in class, and I look forward to seeing you on the next video. Thank you.